Let's continue with our next talk. It is titled, Is NixOS Ready for the CRA? Let's welcome Lukas.
Thank you very much for the introduction. Oh, that's the wrong screen. There we go. Okay, yes, my name is Lukas Beierlieb. I work as a software engineer at Cyberus Technology, mostly with virtualization. I'm very happy and lucky to do a lot of Nix at work. And yeah, sometimes the team lead comes around and said, can you stop the engineering and maybe take a look at this CRA thing? And then I did. And then we would like a CRA talk at the NixCon. You know the most, why don't you do the talk? And so here we are. Okay, first of all, I want to ask you, who has heard of the CRA? So, okay, that's the great majority. And if I ask you to just summarize it in a sentence, who has any idea what it's roughly about? Okay. That's quite a bit less. And who had also the pleasure to look into it a bit more in detail? And all right. All right. Then I hope you can take something away from my explanations here. From my perspective, it feels like the CRA is everywhere. Brought some examples. In March, we were on the Embedded World conference. And basically every banner said, oh, this product is ready for the CRA, or buy our platform, it's CRA ready. Last week was the Open Source Summit Europe in Amsterdam, and there were quite a lot of talks about the CRA and even a panel discussion. And also if you look over at Ubuntu and the Canonical guys, there's quite some presence of the CRA on their blog. And yeah, so CRA, Cyber Resilience Act, I think it was on the slide, but I didn't mention the full name. Most of you heard of it. Anyways, short introduction. Cyber Resilience Act is legislation from the EU concerning cyber security. And you might ask yourself the questions, why does the EU care about software and security? And if you think about the bigger picture, it affects a lot of things. The EU economy can be affected if there are outages due to cybersecurity. The democracy might also be a danger. Think about voting and misinformation. And with a lot of embedded devices or perhaps railway infrastructure, you can also see that cybersecurity can be a threat to consumer safety and health. And the attack surface is, IoT devices, a great example for where a lot of security issues exist. So the problems the EU sees is that there is a low level of security. There are too many vulnerabilities basically in products, and there's not enough security updates that would fix them. And also there's a lack of communication or information from the vendors. So there's no standard way of communicating there are security issues and these issues have been fixed, and it's really hard for a consumer to also make choices. Which product do I buy? Which one can I trust on the updates? Right. And what's the reason for that? There's basically little incentive for manufacturers and vendors to currently address cybersecurity, because if you think about the risks that are in your product and you have to do sandboxing or other thing that takes time in development, and especially IoT is the time to market very important. You want to be first to selling some kind of product to beat the competition. also all the time you spend on security and not making the main functionality work is time that you have to pay for. There's additional cost, which also makes your product more expensive and, in the eye of the simple consumer, less attractive. And if there is a CV, then there's little repercussion for the vendor. The consumers might not even have no bad image. There's little strings attached to basically being insecure in many cases. And yeah, so the EU uses law and legislation to enforce levels of security, which will be mandatory. And in a nutshell, if you have to describe it in a sentence, basically, more focus has to be put on security during development. That means assessing all the risks, addressing all the risks, describing the remaining risks, and also documenting all of it, making it plausible, keeping the documentation around. If the EU comes by and asks, where's your documentation? Do you comply? Then those documents have to be ready. And it's not just in the development, but also manufacturers have to, for at least 5 years, care about the products that they do release. You might also think of devices that launch and then never see an update ever again. That's not allowed under the CRA. For at least 5 years, you have to check for vulnerabilities that affect your product, fix them, and also communicate about the issues. The law is decided, has passed, and will go into full effect in December 2027, so that's a little over 2 years, until every product has to comply, and in about a year, the vulnerability reporting will become mandatory, so that's a bit earlier and not that far until then. What's the effect on NixOS? And perhaps the good news is that, as we know it, not directly. So NixOS is an open source project. There is money involved with the foundation, but it's a non-profit organization. There is no commercial activity around NixOS. So the Cyber Resilience Act excludes specifically such software. And basically all the duties do not apply. Well, who does it apply to? And just in general, it's specified as products with digital elements. You can think of it as anything that somehow can connect to a network. Is it software or devices? If it somehow can connect to the internet and is sold in the EU, then it has to comply. For example, in the NixOS context, if you build an embedded device and use NixOS as the operating system, then you have to comply. If you ship your laptop and buy, design or install NixOS when shipping, then you're kind of selling NixOS with that and you become responsible for ensuring CRA compliance. And also if you make a commercial activity somehow out of NixOS, then the particular vendor becomes fully responsible of taking over the CRA compliance and security updates and everything that comes along. Okay, so in such cases, somebody was to use NixOS in a CRA context, then the perhaps good news is NixOS, with its reproducible build approach, is quite CRA friendly, I would say, certainly more than other distributions. And there are many points that you could mention here. I picked out these 3 topics, which are strong points, but also not as much. And we'll just go through. You get to see a few in particular requirements of the CRA and connect it to NixOS functionality. Yeah. we have 14 minutes now, and it's a bit to cover, so don't expect super in-depth information. It's more of mentioning a few things and giving you pointers for discussion or further research. Okay, so updates, especially security updates, they are mandatory. We talked about it before. And first point is security of the updates. That's not specifically mentioned in the CRA, because basically everything about the product has to be secure and integrity has to be ensured, things like that. I just want to mention here specifically for the updates and how NixOS does its updates. So let's see what's the process if an embedded system, for example, decides to check for updates. Then it looks at its channel or source, hopefully over HTTPS. If you use HTTP, then you will have a problem. But you get it from Git or a tarball somewhere. So you receive that securely. In there, you have all the source hashes in the derivations. And also the packages that you do not build yourself but retrieve from the binary cache, they are also signed. Yeah, so that's covered basically. Also, the CRA requires updates to be automatic. You don't want to wait around for users to update their devices. This will usually take too long, or they might skip. So by default, updates, and especially security updates, have to be automatic. That's easy to do, you might say, within your Nix configuration. That's true, but then again, it gets a bit more complicated. The EU, in my opinion, is really consumer-friendly in that way, and it tells you that the updates, while automatically enabled, have to be postponable, and also you can disable them if you want to, if you have a particular reason to not take them. So yeah, but that's an issue of implementation. You can work around there and implement it somehow. Okay, another alternative I want to mention, which is also more common in the embedded areas, where you want A/B updates, so have one version installed, install another one alongside, and then basically if anything fails, you can use your original version further. There is systemd sys update. That's not NixOS specific. It works with other distributions as well, but it is compatible with NixOS, and I've linked a GitHub project there with a really simple example of performing updates and everything configured in NixOS configuration. Okay, next topic is SBOM and CVE monitoring. So for everybody who does not know what is an SBOM, it's short for Software Bill of Materials, basically a list of all dependencies that your system or software brings along. And the CRA states that you need at least a software bill of material that contains all your top-level dependencies. And that's the basis for which you have to do your CVE monitoring. Look for vulnerabilities for all the components that your software or system consists of. And what's really cool is that you can build that in a very nice automatic way with NixOS. So you have the packages all built by the derivations that specify their inputs, and you can basically build a tree, walk through all the dependencies, get down to the very last package of what's included. Even all your build dependencies, not just the thing that end up in your NixOS image, but down to the compiler that was used to compile a piece of binary. It's the question if you want to track that or not, but it's possible. You can get all the information. And there are tools to do that. I want to mention here the SBOM Nix tool, as well as Bonbon, also very nice names. And okay, how do you continue from there? You have your software bill of materials, and now you somehow have to check if vulnerabilities occur for those packages. And yeah, the thing is, it's complicated. It's not just for NixOS, it's for everybody who does this kind of task. So basically, you have vulnerability databases. There's the NVD, National Vulnerability Database from the US, that seems to become kind of unreliable. So there's now the EU VD and also other open source vulnerability databases, such as the GitHub Security Advisory. And yeah, basically new vulnerabilities are published there, and they're usually tagged with either CPE, as it is with NVD, or EUVD, which stands for Common Package Enumeration, like CVE, but for software packages, or a package URL. And both of these have their strong points and weaknesses, but basically it's tricky to match or find out if a vulnerability applies to you, especially if it's coming from another ecosystem. So the Debian guys or Red Hat have a vulnerability and they report it relative to their package manager, which version it is, and also dates back to Debian version so-and-so. And now you look at your NixOS package and ask, is it the same version that I have? Am I affected? Am I not? And yeah, the problems start even earlier. You might not even have the correct CPE or Perl for your package. There are ways to guess them or predict, or the lists being maintained. I've linked one here that's used for mapping NixOS packages to CPEs, but overall it's a mess, and everything is basically trying to not miss any vulnerabilities, and you end up with a lot of false positive of things that do not affect you, but the algorithms are not sure, and they just mention there's a matching vulnerability. There's a project that's NixOS specific and goes into this direction. It's currently in the prototype stage in the Nix security tracker. Just a short mention here as well, because that's exactly the direction. And yeah, finally, a short discussion of long-term support. So you might know this is not a strong point. So what would be a motivation for long-term support? Like we said, 5 years at least of security updates, keeping packages secure. And well, with NixOS, you can take your release and it will be there for, 7 months. And after that, you don't get new CVEs, or it will not be maintained anymore. And as a vendor, under the CRA, this can be problematic, so you can try switch to the next release. Again, might be lots of work and time that you do not want to spend, but especially you might have problems if their breaking changes too much is different, and you can't get a functionally equivalent new version of your product. So you have to ship it as an upgrade, and at that point, the CRA says, oh, this is a new version, and users have effort to upgrade it, so no, you have to also maintain the other version, keep it secure, and yeah, that's problematic. So for industry, the easiest thing is to develop your product wants, and then basically just make sure it stays secure but not have any functional changes. So from that perspective, long-term support would be great. If you look at the other side, at the people who actually care or maintain the releases, it's the opposite. So short release cycles are a benefit there. So what do you have to do to maintain the release? You have to be on top of the CVEs that occur, and you have to backport the security fixes to a specific version that you support. And that's all right in the beginning. There's not much delta between your version and the newest version. But over time, after a few years, the newest version of some software might be quite a bit different than the current one, and it will be tedious to port back some security fix. Or you might not even be sure if it affects you or not, because so much has changed. And further, the NixOS package set is huge, and doing so much backporting for such a large package set is, let's say, problematic at least. And then maybe, that's finishing off now. The stable version, sometimes mistakes do happen and they're not as stable as one would hope. So a few weeks ago there was this problem where the extra kernel config was renamed and should just be unstable, but it made its way into the stable release. And there was no warning either. Your config just didn't apply anymore. So, which would not be ideal for commercial activities. Thank you very much for listening. We have like 2.5 minutes for questions, and after that, feel free to talk to me over the weekend and share your thoughts on the topic. Thank you.
Will you upload your slides to pre-talks?
Yes, that's the plan. I have to do some exporting and HTML things, but that's the plan.
Hi, thank you for a great talk. I was curious what the scope, like a little bit more clarification on the scope. You said anything that has a digital, runs software essentially. So for instance, I was thinking like, if you get a managed Kubernetes cluster on AWS, will everyone have to go and say, no, don't upgrade my Kubernetes cluster without telling me, or like without me triggering it, because it's a digital element, for instance?
Good question. So there's many edge cases. Not quite sure about your case, but as soon as you basically provide some software in a commercial sense, then you are have to comply. There's something that goes in the direction is like software as a service. If you just host software on your machines and users run the software in their browser, then you're actually fine with running whatever on your machine as long as it's just in the browser of the user. So it's a fine line you always have to check.
Question, how is the CRA enforced?
That's a good question. It depends. So it depends on the criticality of the product. And usually for most products, I think like home device or something non-critical, then you basically keep track of all the documentation internally, and you might be at random checked, or if there's any occurrence, you might be checked. There are, however, more important products and operating systems fall into this category: sandboxing, hypervisors, firewalls, things like that. are considered important or critical, and in that case, third party or certificate is necessary before releasing the product.
Okay, I think our time is up, so let us give our speaker another round of applause.